So, okay, so I'm starting it. Okay.
Okay.
So, hello everyone, and welcome to another episode of Spring of Code. So, this is week 3 of Spring of Code, and we have already gone through a lot of organizations. And today we have very special organizations called GeomScale. And for that, we have Viserian. Thanks again for joining Viserian. Like he will be sharing about how we can get started with the GeomScale itself and what could be the good path of a beginner and how someone like us can contribute to the GeomScale. Like it's such a big organization. So, Sarian, if you'd like to talk a bit about yourself and Geom scale in a broader level.
Okay, so thanks for inviting me here. So GeomScale is actually a small research and development project. So all of us, we came from universities. So we have done PhDs. So actually, it's let's say mostly focused on the research, but we do a lot of engineering too. So the main ideas or the core areas are statistical computing, computational geometry or geometrical computing, and optimization. So we have been to Google Summer of Code twice as a mentoring organization. So this year is our second one, our second in a row. And what else? So, okay, let me share my concerns about this project. So, this happens with R&D projects. We have a very steep level of curve of interaction. So this means that new contributors need to know at least some advanced algorithms and some geometry and some statistics. So this means like that if you want to contribute, you need at least to understand some math. It's not like let's say a project on mobile apps or development for Android. So it's a very specific project. So okay, but I think it's interesting. It has a lot of applications because it's connected to data science and machine learning. So let's say that it's a core tools for data science and machine learning.
Okay.
Okay, so this is more or less the background.
Yeah, yeah, yeah. That is, yeah. I was also going through Geom scale, and it's kind of really fascinating. Like it's covering a lot of broader areas like from data science to geometry computation, statistical computing. Like a lot of folks around here are enthusiastic about machine learning, data science, and they could find GeomScale very helpful, and they could like try to contribute in the organizations and be the part of it, right? And again, congratulations, like GeomScale is taking part in the GSoC for the second time. Like I have also seen GeomScale in the previous year in 2020, and that was also a very good year for GSoC for GeomScale. So, like we do have some questions. Okay, so not much specific for now. So we can like move on to some like how beginners can start contributing.
Okay, so let's say first that GeomScale is hosted on GitHub, so you can find the GitHub, and
Okay. Sorry
then
to interrupt you. Like, are you sharing your screen? Like, it's not shared with me. If you are expect,
okay, let me share my screen.
yeah.
Okay, I want to see the options here. It seems that it's blocked, but I will find a way to do it.
So maybe ad blocker or if you are Firefox, yeah, there's a problem with Firefox too. If you're joining with
Uh,
Chrome, that's all fine.
I think I can share my entire screen.
Hmm.
This could be simpler, or because I cannot find my window here in the list. This is Google Meet.
Much kind of Google Meet, but a little different than that.
Okay. Okay, so entire screen, let's say. Okay. Okay, allow. Okay, so can you hear my screen now?
Yes, yes,
Perfect.
yes.
Right. So this is the landing page in GitHub. You can see that there are a few repositories there, but the most basic repository is volume approximation. So this is for historical reasons we call it like this, because this was started for computing volumes of polyhedral in high dimensions. But since the development was more than volume computation, we did the development there, and we will start forking from there. But still, the main contribution and the main repository is here. So even Google Summer of Code or the project ideas that we have are all inside volume computation. You can see Dinko here, which is a Python library that we are starting now. So this is a baby repository. So you will see news maybe in the coming month. Okay, this is the homepage, the website, and we have a lot of wikis for Google Summer of Code and Google Season of Dogs. So, okay, so the main repository is volume approximation. I will enter here. So this is we have a README, and actually, if you look at the README, you will see the logo and that the description of the library that we call Volesti. So this is a weird thing that we call it Volesti, but the URL here is volume approximation. So there are some issues with small and new organizations that maybe it's tricky for contributors, but I think we have some clear instructions. Let's say, let's start with contributing. So in documentation, we have actually a set of readmes for interfaces of the library, and we have a contributor guide. So first of all, you can see from keywords that the library is a C++ library, and we have an R and Python interface. So here we have if you open this is the README for the C++ library, how you can use the C++ library. Then we have a README for the R interface, how you can build the R interface. Actually, there is a CRAN package. So if you're using RStudio, for example, this can be done by clicking one link, and you can install the interface in local in the RStudio and start playing with the library. And we have a limited Python interface. This will be we are going to create Dingo from this, a new library from Python interface of Volesti. So let's say that the more mature is, and the core of contributions are in C++ interface, and second to the R interface. Okay, and I think we have a useful contribution guide. So if you open this link, this is how you can contribute to Volesti. It's a very, very detailed information and instructions of how you can contribute to Volesti using GitHub. So starting from how to start, how to clone the project, how to test it, here how you run the tests, then how to fork your the repository, and then starting making pull requests. Okay, so all the information is here with screenshots. I think it's pretty straightforward to follow and manage to create your first pull request.
Yeah.
So speaking of pull requests, you have a question?
Yeah. Hello. Yes. So
I will continue with pull requests and issues, but I
yeah,
can
yeah,
make a small I can pause for now if there are questions about the structure of contributor guides and readmes. I
no.
didn't show the code.
Yeah, I guess the question. I guess the walkthrough is pretty straightforward, and it's the screenshot part is really great and quite very easy to follow. So we don't have a question for now. You can we can just get started with the issues and requests, like how we
Okay, so
can.
then if you go, let's start with issues, which is I think the first thing that you land before going to pull request. So in issues, we have a lot of issues here, and we have some labels. For example, refactoring or tests or good for issue. So if you are a new contributor, then just click to good first issue, and you will have a list of the first issues that you can start working on. Okay, and I can give you an interesting example that we have some students come from Google Summer of Code that they want to start contributing. I can see you an example. I can show you an example. So, for example, code coverage. Let's enter here. So I just create an issue and say, okay, we don't have code coverage. Can you help us? By integrating code cove in our and there is a contributor here that user that starting helping us by creating a pull request. So the feature pull request is here. Okay, so he created the pull request with a button and some change in the CMake files, and then we have a discussion, a small review by myself, and then okay, the pull request is not done because the tests are not passing. So here are the automatic tests that we have. So if you make a pull request, then if you make changes in the library, then all those tests should pass with a green tick. Okay, so we are working on this. We are helping the new contributor to create his first contribution. Okay, let's go to another pull request. Okay, we can go to the closed ones and see a new one. Okay, this is a nice example. Okay, so there was another issue here, linked issue. We had this issue. Remove boost libraries from external libraries. And there are some people here asking, hello, may I work on this? And at some point, a contributor just picked it and started working on it. Okay, let's see the work. So here is a pull request. He's asking for us for reviews. We appear here as reviewers. We make the review. And then we discuss. The contributor makes some changes. And then we make another round of reviews. And apparently at the end, This was done. As you can see, all the tests were passing, and the pull requests were finally merged. So hooray, we have a new contributor, and we have a merged pull request.
Yeah,
And then
that's
the issue is closed. Yes, and we are happy. So these are some examples of let's say simple first issues. If you want a more advanced one, like this is a former student from Google Summer of Code. He was working on log concave sampling. For example, you can see a more advanced pull request. So this has this number of lines, chains. We have more reviews. You can see the changes in the files. There are a lot of math. And yes, finally, after more tough reviewing, you can see GitHub cannot even handle this.
yeah,
So there's a lot of stimulating discussions, and finally, yes, we hope that this is also open. We hope that this will end up in the library.
yeah,
This is a very useful feature. So these are two examples of how are our pull requests. So I guess for a new contributor, you can work on something that it's not related a lot with math. And for example, as this remove some library from external libraries, or even making examples. I don't know if I can find such an issue. That was also a nice issue for entry level issue, or a bug, fixing a bug, or documentation. Let's see, improve documentation. Or errors. Yes.
yeah,
This is another example. So yes, just to sum up, I just want to say that there are also issues that are simple, and a new contributor can work on it. And if they want to dive into math, they can do it on another pull request. So we are not a lot of people, but we are committed, and I think we can help. We can give help to new contributors.
yeah. Okay, that's fantastic. So like people are curious about what are the different tech stacks that are being used in the GeomScale currently.
Sorry. What did you?
So yeah, what are the different tech stacks that GeomScale is using? Like for the different projects, what are the different languages and tech stacks being used?
Yes, I think I described this. So we are basically using C++. So okay, let me show you the structure. So if you go to include, this is the whole code here, and it's all pure C++. So
Okay.
yeah, so if
So
you go
yeah,
to
a lot of
hobby
people.
solvers, you can go to leapfrog, and yes, it's
Okay.
pure C++ code. But we also have an R interface, which is here in our project. If you enter here, then you have C++, for example, here, that are wrappers for RCPP. It's a framework for using C++ in R to have better performance. And there are also R functions. So we have also R functions here. And there is another place here, VelocityPy, which is indicated by the name. This is the Python interface. So again, there is C++ here because we have Python to compile and use the Python interface. But there is also Python. There are also Python scripts. So let's say 90% it's C++, but there are some APIs in R and Python.
Yes, yes. So a lot of students have doubts, like they're already doing C++, DSA, data structures and algorithms in C++, C and so is there anything else more required for contributing, like the object oriented? Well, if you would like to talk about the C make object oriented programming approach and something other than that.
Okay, the design is in it's object oriented, but we are mainly using templates, C++ templates. So we are not um, we are having very basic in inheritance without virtual functions. There is no single use. I think we only have one use of pointers in the whole library, so we're not using pointer. We try to write some safe C++. Let's say it's close to libraries like the ones in Boost. There are a lot of templates and no virtual functions and pointers. So I think with some good knowledge in C++, you can become a contributor. But this is very important. You have to understand also the math. So let's say a computer science student or applied math student, after the third or second or third year, I think will have the background to contribute. But as I said in the beginning, even if you don't have the math background, or even if you are not an expert in C++ and you want to play with the library, you can do it, and you can even make small contributions. Like, so we had a few months ago, we had a contributor that create a Docker image for Volesti. So he didn't touch C++ or any statistics. So he
Oh,
just
okay.
created Docker and wrote some instructions how to use it. I mean, you can also contribute in the applications level. Like you can create a tutorial, or you can create if it's useful for your application, you can create a Jupyter or a notebook that with a case study that you use sampling or volume approximation or integration uh, for your application.
Okay,
This
okay,
may,
okay.
may be useful for it.
Yeah, yeah. So if you don't know about the statistics, you can still contribute. Like there's a whole lot uh, area for you to contribute in the organizations, from documentation to
Yeah.
actual projects, from C++ to Ruby to anything other. Like if you have some more features, you can also try and communicate. If you, like people can come out of some features that may not only require C++, maybe some other languages,
Some
other frameworks. So
tests,
that's yeah.
examples, tutorials. I think yes, there is a lot of there is a lot of space.
Yeah, yeah. So this year, you are participating in GSoC, and you are trying to improve your project in some regions. So, if we can know about your ideal list and what are the different places you would like to improve the project, the Geom scale project this summer.
Okay, so we maintain an ideal list here. So this is the yes, this is if you find it on the internet. I guess that one of the pages that you land is this one. Welcome to GeomScale Google Summer of Code Wiki. So this is everything that you need to know about um, applying for GeomScale this summer in the Google Summer of Code. So it's all the instructions here, links are here, and of course, table of proposed coding projects are here. So we have, maybe 10 ideas that are here. So you can, let's say, go to Monte Carlo integration. So there is a description of the background, the related work, the references, publications that the student might need to read. What's the scope of the project? What we want to do. So, for example, integration, we want to integrate a function over a convex region. The possible related software like Stan language or similar algorithms like Miser Vegas here, a lot of information. What are the mentors that you can communicate? And for every idea, we have a set of tests to see if the student is capable to do it. And yeah, so you can see there's a student here that did the tests. And yes, there's a bunch of questions, computational questions of to see if this is related to the project. So every project idea has a different set of tests. Yes.
Okay. So yeah, yes. So in every idealist we have a lot of context written, and that is also helpful for students, contributors, mentors, and one who is just starting to contribute in the report or the organization itself. So that is really great and awesome. Secondly, like what you would suggest to some beginners, like some very beginners, how they can what's their specific roadmap, what should they understand beforehand, and how they could just get started with it.
How to get started? Okay. You go to volume approximation, velocity. You clone it, and you install it. You run the tests. You start playing with a library, and then there are a lot of instructions here of how to do this. Maybe then you can follow a tutorial. We have a bunch of tutorials here, or there is a tutorial from PyData. So you can go to, if you want to do it in R, you can just run all these functions and yes, play with it, change the inputs or change the polytopes. And okay, if you will go to our web page, so this is the GeomScale web page, and you can go to publications. There is plenty of stuff that you can read. You can start with this journal to understand the background if you want to dive into it. And yes, we have talks with slides. If you more like into slides, and yes, and of course you can reach us for any question that you may have.
Yes. So we have a question from Deepak, like how much skill in programming language is required to contribute? A skill
Uh,
specific question.
yes, so I think I described it before.
Yeah.
I can explain it again. So as I said, there are many levels of contributions. You can contribute in the core of the library. So, for example, create a new function or write the new algorithm for sampling from some functions. This means that you should know geometry, statistics, and very good C++. Okay. But on the other hand, you may want to write an example as a start. So let's say that you download the library, you compile it, you play with it, and you want to test it for a new instance. So you can create a new example. This could be a contribution, interesting for us. You may want to, you may have an application on your mind from data science that at some point needs sampling or integration or some optimization. Then uh, you can create a tutorial or some uh, some notebook in R or in Python, some Jupyter or R Markdown or whatever. And you can also help in the continuous integration. So if you are a DevOps guy that or girl that you don't care about C++ or things like that, so then you are expert in CI, then this is wonderful for us. I mean, we don't have the time to do all those. You can create some automated tests or some other routine in GitHub Actions on Cycle CI or Travis or whatever. So or if you are a doc person, then you can start writing documentation. Yeah, a lot of. I mean, it's a new project. It's a
Hmm.
R&D, which means that we focus. The core developers are focusing on doing the hardcore algorithmic stuff and math, and we leave all the uh, things that are essential for open source. We leave it because we don't have a priority there. So there is a lot of space for all the things around that are also very important.
Okay, okay, great. So, like how we can connect with the organizations like Twitter handles or your personal Twitter handler and the like. I know the GeomScale Twitter handler, so I could just paste it in the chat. Like people can follow and connect with there. Uh, but if you'd like to share your Twitter or LinkedIn handles so that people can communicate with you too
Okay,
after the stream.
so there are instructions of communication in maybe we have it in the README. Okay, nice. So in the landing page we have chat on Gitter. If you click on this, you are in chat. I
Okay.
mean, there are 120 people here discussing, having issues, talking about Google Summer of Code projects or whatever, and we are there and we answer to questions. So this is the most quick or active way of communication. You can also send email to the GeomScale account if you want something which is static. But I think the best is to write on Gitter because this is a community thing, right? So this
Yes,
is
yes.
I may no answer, but maybe there is a person like you that had the same problem yesterday. So I think the best thing is to write it on Gitter.
Yeah, absolutely. So guitar is a great way of communicating in the community, and yeah, they can you can connect with the mentors, organizations, peeps, and everyone else here. And it's quite an active community too, so you can get your doubts resolved in some time in very less time. So, I guess we don't have any more new questions, and we have already covered all the basics and about like what geom scale is and how we can start contributing it to it, and what are the different tech stacks that we are going to using, and what are the required skills that you should have earlier, and also talked about like if you can contribute if you don't know statistics and like the mathematics and the C++, you can also contribute with your DevOps skill, Docker skills, say documentation skills. Say like it's a new community and there's a lot of scope for you to shine here. So just join the community and like learn. So in the open source, we already are taught about learn. So like if you can tell more about the learning opportunities students will get when they will connect with the GeomScale.
Sorry, can you repeat?
Yeah. Yes. Yes.
I mean,
So yeah. I was asking like what are the different learning opportunities and what are the different opportunities itself that students could get even after connecting with the GeomScale.
after connecting. So
Yeah.
yes, I think this is a very general question. I mean, it's
Yeah.
like with every any other project. So uh, you contribute to a community which is open. You are helping other people. It's more like this, and you are. I think you are getting also back some experience because uh, it's a nice collaborative way of discussing and let's say learning. But yes, it's not that we provide education. This is the thing. So you are going to learn by doing, and you are going to learn mainly how to collaborate on open source. It's not like it's difficult to find somebody to. I mean, it's not the place to learn, let's say, statistics or geometry.
Oh,
But it's a good. I think it will help people to on their CVs to have contributed to some open source library like this.
yeah.
Uh,
And it's a
and
great way to hone the
if you
skills
want,
too.
yes, this will be useful for industry. If you are
Yeah.
into academia, this is more clear because we are open to collaborating also for writing publications. So this is what we do mainly. We write software and we use it to solve research problems, and we publish. But I
Okay.
think we have connections to both, so it will help you in both ways.
Okay. Okay. That sounds awesome. And we have one more question here from Suraj. Like he's in second year in the university and have a statistics knowledge, decent C++ skills too, and I mean, he's in the community guitar channel already. So, any advice for him? Like, he would be like this year sending his proposal to your organization. So, if you would like to give him some specific tip or the tips to the students in general about their proposals, specifically to GSoC.
Okay, so Google is taking the proposals. We're not taking the proposals. So you submit your proposal to Google. So if you Google it, you will find a lot of information how to write a good proposal. And I also posted in Gitter an excellent proposal that we had in the past from a student that now is an admin. So I think yes, this enough. So participate. The best tip. I mean, solve issues, play with a library, ask questions. I mean, not ask questions that you have after using stuff or after trying stuff. This is the best way to integrate and learn. So a question like I just entered GitHub and I saw GeomScale. What should I do now? It's I mean we cannot answer this. I mean,
Yeah, yeah,
it's very general.
quite
But
funny question.
questions like, okay, I clone the project, I run the tests, and I find a volume which is I think it's wrong. Why this is a volume like this? So this is a main. Yes, this is more basic.
Yeah. So
Okay.
the conclusion is like, don't ask generic question and research a bit more before asking questions. Like
Yes,
if you,
I mean, you
yeah,
can. I cannot help more than nobody can help more than searching on Google. So I will Google it myself. I mean, it's
yeah,
this is the main thing. So it's yes, asking specific questions helps everybody, I think.
yeah, definitely. Like yeah, so a good question helps others too, and a good question motivates maintainers too, and it also, you as a student, if you ask a really good question, you stand out in the crowd too. So, and asking gendered questions like as you mentioned, will not put that much impact, but if something can be solved with the googling itself, and you're just repeating your questions in the guitar channel just to get some attention, so that is really not good. And you should first try and some work, do some work to solve that issue, that what you may be getting, and then try to ask questions if you're getting some more issues after that. That should be the perfect approach, I guess, right?
Yes, and okay. So one last comment. If you like the project and you want to say something about the project, it's there is a magic button, so you can follow my mouse. You can go here and start the library.
Yeah, very important.
Give, give a start to the library. I mean, it's yes. If you think you like it, you can. It's very quick. Then you should do a hands-on. I mean, you should install it and try. And I think so. If there is something missing, this is also a good question. I mean, I want to install Volesti in Raspberry Pi, and I didn't find any documentation. I mean, something that is missing. But if it's there, I think it's good for the students or the new contributors to search, because if you are not searching, and yes, it's not easy to integrate and learn.
Yep. So can't
Yeah.
agree more. Like that's really great words from you. Uh, I'm done with the test writing readme at the moment. Yeah, so he's right now contributing to you GeomScale, and he's just sharing about his experience and things. So I guess if you care, if we have some more time with Viserian. So if you have some questions, you can ask in the chat, and that's once in a lifetime opportunity for you all. So keep asking. And secondly, like do start the GitHub repository, and I already have pasted the Twitter links, LinkedIn's, and do follow it on the handles, social handles, and join the community channel on the GitHub. Like I have already pasted all the links there, so you can definitely go check that out. Give a star. That's a magic button. Yeah, great. So yeah, we can wait for 5 to 10 minutes, 5 minutes more if we have some more questions. And yes, so so I guess we don't have any more questions here, and and thanks again, Visarian, for joining. And it was really a very great session, and it's kind of a very insightful one where we can where we learned a lot more stuff about GeomScale itself and how we can start contributing to it. And that's really a great session. So we can take your leave, and thanks again for joining. And if you want
Thank you
to
for inviting.
close, yeah, if you want to have some closing remarks or closing words from your side, it would be really great to hear.
Uh, yes, I think I I think I said more than expected for from me. So I think, yes, first of all, thanks a lot for doing these sessions. I don't see. I mean, I only see you and maybe some comments there. I don't see if a lot of people attending. So I think this will be. I hope and I think that this will be helpful for a lot of people.
Yeah,
And yes, keep
and yes.
contributing.
Yeah, that's very important. And secondly, this video will be there for the lifetime. Like, if anyone in the future wants to contribute to GeomScale, they could just search it, like how to contribute to GeomScale, and it will pop up on the YouTube itself. So it's not only helpful for now for the this year student, it will be also helpful for the students that who will be contributing to who will be referring it to in the future too. So future students, past students, everyone is helped. So thanks again for joining, and thanks everyone for joining the stream. And we can take your leave. Goodbye. Take care.
Bye. Thanks.